All right, everyone. Welcome to the first ever Solid Experience Mechanica Markforged Roadshow. My name is Stephen Murphy here. I'm getting us started out, but let me just give a few extra seconds as everyone's trickling in here, and then we'll get started. All right, we'll go ahead and get started now. Welcome, guys, to this webinar on the future of additive is now. My name is Stephen, and what we're going to be doing today is we're going to be taking a look at the future of additive manufacturing and how companies are leveraging additive manufacturing today in order to meet their objectives for their company. Just as a brief agenda, we'll go ahead and start off with an introduction, move into 3D printing and manufacturing, kind of where we are right now. We'll talk about the Markforged platform and the specific process that Markforged has. And then we're going to wrap this up with talking about real customers getting their real value right now. So we're going to talk about a bunch of case studies on how people are actually using this technology today to generate revenue. And then at the end, we'll wrap it up with a Q&A with a panel of our experts just to discuss your questions. If you have questions at any time during the presentation, just go ahead and use that GoToWebinar chat section and type in your questions, and we'll answer those as we go along or at the end, depending on what they are. So, without further ado, my name is Stephen Murphy. Here I can toggle on the webcam. I'll leave it off most of the time just so that it's not too terribly distracting. But I'm an applications engineer working out of Nashua, New Hampshire, and I specialize in additive manufacturing and Markforged. And what I'm here today to do is to kind of update you on where we are with the technology and what value it adds to each and every company. So, talking about the big questions, why are you here? Well, obviously you're somewhat interested in additive manufacturing and Markforged. You know, I can't necessarily answer all the questions about the cosmos, but what I can do is I can bring you up to date on what we know about 3D printing and how it's best impacting the businesses around us. And in general, a lot of 3D printing conversation is just at the very tip of the iceberg. And what I want to do today is I want to get down into the greater detail of why it matters, what we can do with 3D printing, and how you can actually leverage 3D printing inside your individual industries. So let's start off with talking about how additive manufacturing has impacted the manufacturing market. And to start off, the most basic benefits of additive manufacturing are improved speed. So you're going to be able to create your parts faster than before. You're able to reduce your downtime. So you're no longer waiting on long lead times in order to produce your parts, fixtures, and jigs. And finally, you have greater yields. You're able to find manufacturing defects and mistakes earlier in the process. So in extension, you're able to fix those and have a more consistent product. But how does that transform your business? Well, obviously the lower production costs help you to improve your ability to compete. So you're spending less time, less money on getting your part to market, which is a clear benefit. Also, you free up machinist talent. One of the biggest misconceptions with additive manufacturing is this idea that you're replacing the job of the machinist or your manufacturing engineer. But as I'll show you throughout this presentation, it's quite the opposite. What it does is it provides a tool for your manufacturing engineer or machinist to use to better produce the product that they're manufacturing. So rather than spending time making the jigs and fixtures and tooling, they're instead going to be able to focus on actually producing customer-facing parts. Obviously, there is a big improvement in profitability when you have greater profit margins on the parts you're making because of the cheaper fabrication process. You're also able to shorten that development cycle. So because additive manufacturing allows you to generate parts and create parts faster, you find problems faster, which means you get to Rev 2, Rev 3, Rev 4 in a much quicker time, saving you money down the road. You also have this faster changeover and production scaling, meaning that rather than having to sit on a ton of product in order to change over, you can focus on having a more digital inventory to reduce your overhead. And this moves into the last point here, that we're reducing inventory costs by having to only create parts that you need instead of just keeping the correct number on hand if something goes wrong. So less waste. So there's a lot of change coming from generic additive manufacturing in not only the manufacturing realm, but also in many of the other businesses adjacent to the 3D printing movement. But let's talk specifics, all right? I don't want to just sit here and tell you that the world is changing and everyone's using it. What we're going to do now is we're going to take a look at one of Markforged's customers, Caldwell, and what they're doing with additive manufacturing. So real quick, I'll go ahead and just start that video. Everyone should be able to hear this video. If not, check your settings inside of
At Caldwell, we make components that go into windows and doors that are sold around the world. We've used the Markforged printers to make everything from prototype all the way through low volume production pieces, tools, and fixtures to aid in manufacturing for assembly and/or test and measurement.
In the past, an engineer would need a part made and I'd have to estimate how long it would take to machine that part. Some of those parts could have 40 hours of machining in them. Today, with the Markforged printers, an engineer will give me a drawing and the first thing that comes to my mind is I want to use the printers.
This fixture to machine traditionally would probably cost 5 times as much and take 2 weeks to manufacture. I printed it in a day and they were able to use it that same day.
This is a production assembly. This is a prototype assembly using both composite and metal 3D printers. This assembly allows you to tilt your windows in for cleaning. Having the ability to 3D print our own metal components has really improved our development process.
The similarities between what we'll print in stainless steel and what we would cast in stainless steel is just incredible. That's something we can get in 2 days in our own lab. The hardware we manufacture is what holds the window together structurally, and if that were to fail, it can mean severe damage to a building and major disruption for someone's life. The strength of the 3D printed parts that we get off the Markforged machines allow us to put those parts through the same set of conditions that we would test a production piece. They're real parts that have actual strength.
In this highly competitive world, you need every advantage you can get to produce the parts, do your job, have a leg up on your competition in every single part of the business possible. And 3D printing is huge to help us do that.
All right, everyone. So that is Caldwell, one of the customers of Markforged specifically, basically leveraging additive manufacturing in order to, come to market faster, in order to beat their competition. So the next phase of our conversation, let's talk about Markforged specifically, because there are a lot of additive manufacturing companies out there. And what we want to do today is we want to understand where Markforged stands in the additive manufacturing industry. So we're going to kind of look at 4 different areas on why Markforged, or on why you would choose to work with this Massachusetts-based company. The first draw to Markforged is their comprehensive portfolio. So with Markforged, you're able to print in plastics, composites, and even metal. So this wide range of industry standard materials is one of the huge draws to Markforged. Now with those materials, we're able to achieve a better strength and accuracy than most other 3D printing companies. So you're able to get the results you need every single time. They're highly consistent, and the printers themselves are optimized to be plug and play. So it's easy to operate, it's accessible, and they're very fast to integrate into your current workflows. So the third kind of area that puts Markforged on the map is the idea that you don't need a whole ton of training to work these printers. Most of the time, anyone with a simple understanding of components can use these printers without much hassle. And finally, there are basically an innovation leader. Markforged has been leading the forefront on not only composite technology, but also on AI technology. And they're working on developing a blacksmith AI, which leverages machine learning in order to get higher tolerancing and better quality parts every time. So let's look at these particular details. For the industrial printing platform, there's a robust range of offerings. So here on the left side, we're starting with the industrial 3D printer. But we have a full range of composite-based printers that allow you to create components that are as strong as 6061 aluminum. On top of that, with our industrial materials, you're able to create components that are usable as parts within your manufacturing shops. So we're not just talking about pretty prototypes that someone sets on a desk. We're talking about industrial materials used day to day for engineering. And finally, we're going to be looking at the enterprise software and how their Eiger software makes it extremely easy for any user to pick up the software and to manage an entire fleet of these products in one individual dashboard. In terms of the industrial 3D printers, here's the lineup. Going across this, from left to right, you have the original desktop Mark II printer with the ability to do both plastics and composite parts, followed up by its stronger industrial printer cousin that has faster print time, more advanced material, and additional hardware to improve the accuracy of your 3D printed components. Then the next three parts are part of the metal printing process. So the Metal X printer, the Wash 1, and the Sinter 2 are each components that we'll get into more details about in order to 3D print metal components. Now, let's talk about the materials we have to offer. The Markforged printers give you a lineup from plastics to composites to metals, a full range of product to match the solution you need. And you can even make hybrid parts. The idea that you can use metal components that are wear resistant and have a stiffer hardness, while also using composite components in order to decrease the weight and to have a faster print time and a faster turnaround. So here we're able to leverage all the technologies, all of the Markforged portfolio in order to create better products that we need. And all of this is controlled from the enterprise 3D printing software called Eiger. So here I'm going to show you a little bit of the Eiger software itself. And this Eiger software allows you to have a parts repository. So here, as we go through this cloud-based software, we're able to filter and find specific parts and components that have been created before or that we want to create now. Using this filtering, we're able to go ahead and we can import any STL file and start creating our metal printed part. Very easy to use. The slicer allows you to just click on any individual face, set the material. Note all the materials that Markforged has to offer are through this same Eiger platform, so there's no learning new products as you grow your business or grow into the Markforged portfolio. you're able to add multiple types of parts to the print bed itself at the same time. So in this case, adding multiple metal components to be batch printed on that Metal X 3D printer. And from here, when you go to print, we have tons of information about the fleet. So we're printing to one individual printer. It'll give us estimated print times. It'll tell us when we're done. But on top of that, we're able to manage a fleet of printers all at once. And with this part repository, it's very easy to go and find your part. So in this case, we want to take a look at some of the benefits of composites. So looking at a carbon fiber part, we have this slicer with the ability to go in layer by layer and set up either isotropic, concentric, or both for your fiber layout. And you can quite literally go to individual faces and features and set up your part to maximize your strength to cost, meaning that you get to decide how strong you make your parts with the flexibility of the Markforged printer. But let's take a step back and look at the Markforged composite technology a little more closely. So everyone can relate to the idea of rebar and concrete. The idea of rebar and concrete is that you have these strands of rebar within your matrix of concrete, which provides a significant increase in the overall strength of your concrete. The Markforged printer works in the exact same way. So we use fiber materials, carbon fiber, fiberglass, Kevlar, inside of our matrix of material in order to print stronger parts. Now, how strong are those parts? Well, the parts we're able to provide with composites, so with a plastic containing that carbon fiber support, we're actually able to surpass the strength of 6061 aluminum. So one of the benefits of being able to use this continual fiber part is that you have components with the strength of metal with the weight of a third or a fourth of the initial metal part. They're also extremely durable. So you're able to get a lot of strength from those fibers beyond your traditional plastic. So when you're comparing the Markforged components with, say, a standard ABS or PLA, we're talking a completely different level of durability. And last but not least, they're optimized for performance, meaning that you are able to control how that fiber is laid in order to maximize how you're taking advantage of the strength of the fiber. You can tailor your fiber in order to support holes, in order to prevent bending, in order to avoid torsion. The choice is yours, and the Eiger software allows you to easily set up your parts in the way that's going to best support your specific challenge. So for anyone who hasn't had a chance to work with a 3D printer before, let's talk about how it works. Basically, you create your part inside of CAD, so a program like SolidWorks or CATIA. From there, you just export the STL to the Eiger software. Again, that Eiger software is a cloud-based software where you are able to slice and reinforce your part. So you go in and you'll set up your carbon fiber Kevlar inside of your part or component. Then you print. It's as easy as that. With the way Markforged has set up its printers, there's not any extra steps. You don't have to go and play with a ton of settings to make it work. You are very easily able to just create parts on the fly. And here's a good example of what that part actually is. So we have our matrix material. So in our case, we have a material called Onyx. Onyx is a nylon-based material with chopped carbon fiber in it for extra strength. And we have continuous fiber. So this is that rebar, this is that ability to add extreme strength to our part. And the fibers we currently have are carbon fiber, fiberglass, Kevlar, and high temperature, high strength fiberglass. And this allows us to get a better strength to weight ratio than 6061 aluminum. So oftentimes everyone asks, well, how do you pair up with other parts, with other 3D printed material? As you can see, one of the most common 3D printed materials, ABS, is at the bottom of this stress strain curve. we're able to use the correct tool for the correct job. So for example, carbon fiber has the best strength to weight ratio possible, whereas something like fiberglass is very cheap and is more cost effective, meaning that if you want to make lots and lots of iterations, you can start out using fiberglass and then move into the carbon fiber. Kevlar has a lot of awesome properties, mainly that it's highly impact resistant and that it doesn't deform plastically, meaning that it won't fail like a ceramic, instead it'll deform like a plastic, giving you a better fail condition. And last but certainly not least is the high strength, high temperature fiberglass, which has a heat deflection temperature of 150 C, which is about 300 degrees Fahrenheit. So when you combine that with onyx, you're able to withstand higher temperatures than the majority of 3D prints. Now, if you're familiar with the Instron test, the idea is that we're providing force on both sides of this chain link. This chain link was printed in the X7 printer, and we're pulling apart this carbon fiber supported part at what is over 22,000 pounds of force before it breaks. So here, the part breaks, but what are we talking about when we say 22,000 pounds? So that's one unloaded cement truck, 6 2009 Ford Tauruses, 19 grizzly bears, 1.6 T-Rexes, or 1,500 bowling balls. So when we're talking about the strength of continuous fiber, we're talking about real usable engineering parts that can bear weight and that can replace metal components in many, many situations. Now, moving to the next portion of our discussion, let's talk about the metal printing technology, because Markforged not only has a plastic solution and a composite solution, but we have the ability to print metal. And some of the really important things to note about the Markforged Metal X printer is that it is very safe. There's no loose powder, so it's much safer and less expensive than traditional 3D printed metal parts. It's very easy to use. There doesn't have to be a specialized operator. You don't have to EDM your parts off the print bed once you're done. And you are able to batch process parts. So using the sinter and wash to create batches of components all at once. So there's a number of benefits for using 3D printing here when we're talking about the metal side. Specifically for Markforged, you don't have to have the tooling. So many forms of metal fabrication requires a lot of tooling. Specifically casting, bending, extruding, everything requires more steps following your initial print. Whereas with the Markforged metal printing, you just need to run it through the washer and sinter, and then you have your completed part. Also, you don't need a ton of fixturing and jigs, so you have minimal overhead in terms of the tooling required for traditional metal fabricated components. Also, 3D printed metal, specifically Markforged, makes for an automated process. You don't have to have someone creating CAM program. You don't have to have someone watching the machine. You don't have to have somebody who's highly specialized creating the components. Instead, you're just putting it through the Eiger slicer and you're printing the parts with no observation. So it is much more efficient and much more automated. And finally, we have the geometric freedom. So anyone who has ever fabricated a part knows that there are certain limitations. You can't make certain overhangs, you can't do certain shapes or sizes. With the Markforged metal printer, a lot of those constraints are gone. So you don't have to have the same set of limitations that conventional metal fabrication usually has. Instead, you're able to design with more freedom and create the parts in the shape that you need rather than in what your manufacturing process can handle. Let's talk more about the actual print cycle. So how does this Metal X printer work? Well, as a brief description, we start off with printing the individual component. So you take the part exactly like you would in the composite, upload it to Eiger, and you start the print on the Metal X machine. Now note that you don't have to do anything special with the CAD model. Because of the Eiger software, it compensates for your shrinkage in this process so that the part that you want is the part that you design, is the part that you get out of the sinter. You don't have to worry about any of the equations. You don't have to worry about the shrinkage. It's all taken care of for you. Once you have that green state printed part, you put it over the wash where it goes ahead and removes the wax. The material that the Metal X printer uses is a powder material that is also combined with a wax and polymer. The combination means that it is actually a spool of material, which is how we get around any of the dangers that powdered material would conventionally have. And then the final step is the sintering process. That's where you're going to go and burn off any of that remaining wax, and you're going to atomically diffuse your metal component together. And after the sintering, you have your metal part. And it is a metal part, meaning that you can do any of your standard post-processing operations in order to get the tolerancing or to get the shape that you want. Now here, let me bounce you over to Trip to show you the Metal X in action.
Hey everyone, I'm here to talk today about the Markforged Metal X process. It's a simple, safe, and cost-effective method to go from design to functional metal part. There are 3 steps in this process: printing, washing, and then sintering. First, let's start with CAD. You design your part, then export to STL and upload into Eiger. Eiger is a cloud-based slicing and print management system that comes with every Markforged product. This automatically configures your part based on the material and printer you've selected. When your part slices for metal 3D printing, it gets scaled up to account for shrink and deformation in the downstream processes. It then slices your part into discrete layers, identifies overhang features, and builds supports and a raft underneath your part. As we go through printing, washing, and sintering, Eiger will monitor the part's progress along the way. Let's start this print and go to the Metal X. Before starting a print, the machine automatically maps and levels the bed to ensure the first layer goes down well. Your print is built of 2 materials stored in this heated chamber above. One of ceramic release material and one of the metal to be printed. This filament material is metal powder safely suspended within a 2-part plastic binder. It gets heated and extruded onto the build plate where the part is created layer by layer. The release material gets extruded as an interface between the part and its supports, so that once your part comes out of the furnace, it's easy to remove. Unlike other metal 3D printing systems, this process does not require loose metal powder, resulting in a safer and more cost-efficient workflow. 17.4 stainless steel is loaded now. However, with a quick changeover, the system is capable of printing in stainless steels, tool steels, coppers, Inconel, along with several other materials currently in development. Once your part is finished printing, you'll get a notification. At this point, you can go to the printer, remove the part from the build tray, and clear the bed. Now we have what's called a green part. It doesn't really look or feel like metal. However, a large part of it is comprised of metal powder. Next step will be putting it into wash 1 for the debind process. The wash 1 removes the first stage of the binding material. A green part is taken from the printer and placed into the wash basket, which is then lowered into the solvent. Wash times will vary, ranging from a few hours to a few days, depending on the thickest region of your part. After that, it's now called a brown part and is ready for sintering. Let's go over to the furnaces. This is Sinter 2, a furnace designed for mid-volume production runs and larger printed parts. Sintering transforms a print from a lightly bound collection of metal powder to a fully finished metal part. First, the temperature ramps slowly to burn away the trace amounts of remaining binding material. Then, temperature ramps closer to the melting point of the material, allowing metal particles to start to fuse together to create a strong metal part. Markforged sintering furnaces use a carbon-free retort to ensure part quality and alloy composition standards are met for our finished pieces. Each run takes about a day and can be monitored remotely using the Eiger software. Once a run is complete, the setter tray full of finished metal pieces can be removed from the furnace. Once removed from the raft, these parts are ready for use. In the furnace, the layer of printed release material between supports and the raft and your printed part remains powderized. This allows the structure to be tacked to the raft to better control shrink and accuracy throughout the process, but also an easy release after sintering. At this stage, your part is fully sintered and ready to be used. It can be post-machined, polished, or otherwise processed as necessary for the final application, but in many uses, the accuracy and strength are good enough as is. It's ready for install. Check out markforged.com for more information about our simple, safe, and cost-effective method of metal additive manufacturing.
All right, so that is how simple the metal printing process really is. The question that I know everyone's thinking of right now is, what metals can we currently print in? So, as of right now, there are 6 metals that we're able to print in with the Markforged printing process. A few tool steels, so we have A2, D2, and H13 tooling steels. We have 17.4 pH stainless steel, and just recently we were able to add on copper and Inconel 625. So copper is best known for its thermal and electrical conductivity, ductility, and machinability. So we're very excited to have that as a metal that is currently released and ready to go. Also, Inconel 625 is very cool because of its difficulty to machine with conventional methods. Being able to 3D print that will save your machinist a lot of hassle. Also in the pipeline, titanium and 316L are currently under development. So I know titanium is one of the most sought after material that we have here because of its lightweight applications and its high strength as well. Now that we have kind of discussed what the printing lineup is, let's take a look at how people are using the printers, because I think that 3D printing most of the time has this stigma that it's not ready for development, we'll get to it eventually, that, you know, it's a future technology but isn't good enough for the limelight yet. And honestly, at this point, those people are behind the ball, because we have a ton of customers creating parts, creating sellable components, and saving a ton of money. So, for example, Caldwell, we talked about them earlier. They had a nice little video discussing their individual pieces for the window manufacturing industry. And they were able to reduce their product development time from 6 months to 6 weeks. That is a huge save in time, and they're able to reduce their part cost by 10 times. So that's taking something, from the ground up and being able to create products faster than the competition. And as I noted earlier, this isn't just a technology that the CEO likes, or just isn't a technology that the engineering manager likes. Every single person who interacts with this technology loves it because it makes their lives easier, it makes their bottom line better, and in this case, you're not replacing a machinist. Instead, you're augmenting their ability to work and making their lives go much, much easier as well. So as we see in Caldwell, every tier of individual working there enjoys using the 3D printers and has the ability to do their job better because of it. Another customer we want to talk about here today is Lean Machine. So Lean Machine is actually based out of Saskatchewan, Canada, and they are a CNC fabrication shop. And they're able to have access to, right now, both the composite and Metal X printer. And what was happening is that tooling cost was really slowing down their development. So what they took a look at is printing these end of arm effectors in 17.4 pH stainless steel in order to build their machines faster, in order to build their robotic cells faster, to automate their industry. So now we're going to take a look at exactly how this company, Lean Machine, was able to make this transition.
One of the big challenges we had with the bending cell was to basically design and integrate everything in a really timely fashion. We were able to actually do it in about 6 months, and that would not have been possible without the additive. We found Markforged by researching for the best printers out there for commercial and industrial quality printing.
One of the parts we make at Lean Machine is an aluminum wire clip like this. The tooling in general, what we used to use was big heavy steel tooling like this to put in our press brake. So one thing we found we could do with printing was actually print these tools instead. The big thing that we saw with Markforged was it took a big step from a hobby printer to something that you can actually make parts out of. And we saw a few sample parts and then we kind of jumped in with it and haven't looked back. So the first step is that you load the blanks into the trays, which hold 200 parts each. After that, the robot picks the parts out of that tray using an array system and then takes it into the press brake to bend them one at a time. Because of the 3D printing, you have complete control over the profile of your bend. The onyx is actually very good for friction and it doesn't leave any marring on the part at all. So we have a much nicer part with the printed tooling and it's easier and cheaper to make the tool, so it's kind of a win-win.
With the continuous fiber, you make a printed part that not only could compete with aluminum parts, but in many cases actually be a better part. So one of the biggest real gains that we found with the 3D printer is that if we want to get parts made, we don't have to go and schedule them out in the machine shop. We don't have to order tools. We don't have to make drawings. We can skip all of that and we can just get the parts made on the printer. We come in the next day, the parts are ready, we can start testing with them. And we don't have to go and check that they're right. And being able to have every single feature on a printed part coming out within 2 or 3 thou with Z accuracies of less than a thou. I mean, the accuracy stuff is huge.
As soon as we heard about metal printing, it's the next level. So we started looking into it. We're excited about it because, I mean, if we can make some tools work really well out of plastic, it kind of blows your mind what we could probably do out of steel.
For the grippers, they'll just look really awesome on there. The metal printed parts look nicer than most machine parts. We just keep bending thousands of parts and the tools are not wearing. They're just bending perfect parts. It's like, okay, these guys can pretty much do anything.
So with that strategy, with that use of the Markforged technology, they're able to get 75% cost saving in their process. And on top of that, they're able to create these parts 5 times faster. What it also did for them is that they're able to have their machinists working on more important, more difficult parts and components down the road as well. So a really big step in manufacturing for sure. Another example customer we have here is Nika Systems, and basically they're a manufacturer of mining and cement lab equipment, and what they're doing is they're creating these brackets that are out of Inconel 625 material because they need to withstand temperatures up to 1,000 degrees centigrade. So in order to make these components, they were having them 3D printed, and we were able to create a 1-for-1 replacement. So the left one is the one actually from the Markforged 3D printer, whereas the right one is from the traditional DMLS technology. So that's another type of 3D printing software here. And here, now it would help if I actually showed you that that slide, where we're comparing on the left side again the metal 3D printed component from the Metal X printer compared to a more traditional, more expensive metal printing component. So for them, they were able to save $108,000 in the first year and decrease their lead time by 86%. So this is a huge cost savings that was able to basically pay for the entire machine within a year. And as many of you know, for capital machining, that's basically unheard of. Now, more on the composite side, let's take a look at Wärtsilä. They're a company out of, I do believe, Finland. Basically, they are one of the world's largest cargo shipping company overseas. And what they're running into is that their metal components for shipping, so this is made to pick up heavy objects like engines, was too heavy. So what they did is they actually developed a way to make these tools out of composite printed materials, basically carbon fiber supported onyx materials, in order to have a much lighter component which led here to them being able to use parts. This part is a onyx-based carbon fiber supported component that is CE certified and was actually the first ever CE certified 3D printed lifting tool. So just to give you an idea of the scope of the strength of these materials, we're not talking about, you know, your little plastic parts everyone conventionally thinks about with 3D printers. We're talking about a part that is as strong as metal, but is 75% or 25% of its original weight. So you're saving 75% of the weight, which in this case allows you to pick up more. It allows you to store them more easily. And rather than having to do a two-man lift in order to pick up some of this equipment, instead, anyone can pick it up and move it into position with one hand. So this is a huge, once again, application of 3D printing without necessarily having to make a huge investment. So this is with the composite printer. Another fun thing to add in here. So this is actually the Mark II and X7 3D printing, 3D printers based out of the Nashua, New Hampshire office. And what we've been doing to combat COVID-19 is we're creating face masks for Mass General Hospital. So the idea here is that we have printers running around the clock in order to create the masks, except for obviously the plexan that goes in front. And we're able to produce actually 50 masks to help out with our emergency responders in order to, you know, stop the spread of COVID. So that's something kind of cool that we've been working on in the US office, with the idea being that the flexibility and the ease of use of the printers have allowed us to create these individual parts. Now, as we wrap up here, the idea is, what are you waiting for? The Eiger software, you can try at any time. So that slicing software with all those capabilities, you can log on to markforged.com and create a free account and try it out. We also have a bunch of specialists who would be more than happy to walk you through your individual parts and discuss your situation and how Markforged could best help you. So here we have some time for some questions. I'll go ahead and open up the chat here, see if there's been any questions going out. So far, no questions, but I'll give everyone a couple minutes to write in any questions that they may have about Markforged or about the metal or composite printing processes. And I'll invite any of the other organizers to jump on here and say hi if they want, but let's see. Do we have any questions? Give everyone a few minutes to be able to write their questions in, but all right, Nick wants to know, what is the size of the Sinter bed, John?
The Sinter 1 is roughly 9 inches by 4. The Sinter 2 is actually a 2-level bed. You have that lower bed, and then you have another 5 by 9 inch bed on top of that. So you have a double stack in the Sinter 2. Or you can take the double